Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS, we have completed normalization concept. And today we are going to start a new concept which is relational algebra. There are so many query languages in DBMS. One of the query languages is relational algebra, right? So today we are going to start the relational algebra. In this session, I will introduce the basic operators in relational algebra. Let us start the session. What are query languages? The languages which can be used to answer a query is query language. The query languages are mainly classified into two types. What are the two types, sir? The first one, procedural languages. What is meant by procedural languages? In procedural languages, we need to specify what we need and how to get it. So we need to specify what is our requirement and how we need to get it. That is the procedural language. The best example for procedural language is relational algebra. That is what we are going to start today. The next one is non-procedural language. In non-procedural language, we need to specify what we need. How to get, that is not our responsibility. It is the responsibility of the DBMS software. So, in non-procedural language, we will specify what we need. What are the examples of non-procedural? Relational calculus and SQL. So these are the two examples of non-procedural languages. After completion of relational algebra, we will start relational calculus followed by SQL, structured query language. That is a roadmap of this query languages topic. Now let us start relational algebra. Operators in relational algebra. Like operators in mathematics, addition, subtraction, multiplication, we are having some operators in relational algebra. So relational algebra is a language which is used to communicate with DBMS. To communicate with the database. So what are the basic operators? The first one is selection. This is used to select the particular rows of a given relation. That is, it is used to filter the records. The next one is projection, which is used to filter some columns. Suppose a relation is having some 100 columns. I want to know only 3 to 4 columns. Then we will use projection operator. The next one is cross product. In general, the cross product is used to combine two or more relations. Union. When we are having two different relations, we can apply the operation union, like in our set theory. And set difference. That is also what we have learned in our set theory mathematics. And the next one is rename. Whenever we are having a big procedure to solve our question, in the meanwhile, we need to rename some of the results to have more flexibility and more understandable of the procedure. So it is needed sometimes to rename the results. Then for that purpose, we will use this rename operators. These are the basic operators of the relational algebra. In addition to these operators, we have 3 more operators, which are derived operators. What are derived operators, sir? Why we are calling them as derived? Because those operators can also be obtained by using these basic operators. That means if you want to use, you can directly use the derived operator. If you don't want to use it, you can form it by using any one of these 6, by the combination of these 6 operators. Then what are the derived operators? The first one is intersection. How to get intersection? That we see, sir. For example, let me give, if you are having some knowledge about mathematics, A intersection B is given by A minus of A minus B. That means the intersection symbol can be expressed in terms of the basic operator symbols. So that's why they are called derived operators. The next one is natural join. After applying cross product, we will filter some of the records in the result so that we will get natural join. So natural join is a special case of cross product. We can treat it as like that. Then the next one is division operator. These three operators directly we can use, or we can form them by using the combination of these 6 basic operators. So this is the story of the operators in relational algebra. In this session, we are going to discuss the first 3 operators. So that's why we name the session as Basic Operators Part 1. In Part 2, we discuss the remaining 3 operators, and then followed by derived operators. This is the planning, sir. Now let us continue the basic 3 operators: selection, projection, cross product, on some of the previous year questions on these symbols. Right? Let us start it. Selection. Why we are using it, sir? We will use it to select rows or records. What does it mean? Suppose I have collection of all the employees. Now I want the details of employees of only CSC department. That means we are filtering, or we are selecting some records based on the attribute. In such case, we use this selection operator. Suppose we have a table student in which we are storing the attributes SID, student ID. That is my intention. Name of the student. 6, the gender of the student. Department, the department in which the student is studying. Right? Suppose I want to list out all the details of the students whose name is Sita. That means among all the records, I want the details of records in which name equal to Sita. In general, the symbol for selection is sigma. From which table you are selecting, sir? From student. So sigma of student. If you write only this expression, it will give all the records of the relation, because we not specified any condition. Now we know the name equal to Sita. So we specify the condition here. Name equal to Sita. Then what will happen, sir? It will give the records. It will give the records whose name is Sita. In this relation, I have only one record whose name is Sita. So it will display the details of Sita. Am I clear in this, sir? Let us do one more example. List the details of student whose ID is 55. The same story. Now we are making query by using ID. Select from the table student. Then what is the condition, sir? I know student ID is equal to 55. So it will give the details of the students whose ID equal to 55. I may get one record, or I may get more than one record, depending on the property of the attribute. Suppose I have a student with rule number only 50. I have only one student with rule number 55. Then I will get only one record. Right? Let us do one more example. List the details of girl students. What does it mean, sir? Sigma of student. Now we know the gender. So that means 6 equal to girl. Right? So in this case, what will happen, sir? We will get the details of all the girl students. What are the girl students you are having, sir? 11, Sita, girl, EC. Similarly, we have 77. Achha, I think we have second one, Rama. Right? So 33, Rama is a girl, sir, and her department is CSC. Similarly, 77, Roja. So the result may produce more than one record also, depending on how many records are satisfying the specified condition. Now the next one. List the details of CSC department girl students. That means I have two conditions. One is department must be equal to CSC and gender equal to girl. So we need to make the query from student. And what is the first condition, sir? You can write any one of the conditions, sir. The first one is she must be a girl. And for and we will use this symbol, sir, the conjunction symbol which we are using in mathematics. So the next one is department. Department equal to CSC. Hope you understood it. So this is about how to filter the records from a given relation by using selection operator. So now suppose when coming to SID, we have used whose SID equal to 55. Instead of equality, I can use less than, greater than, less than or equal to, greater than or equal to, not equal to. So these are the relational operators which we can use on numerical operators. Clear, sir? And what are the logical operators? Let me write it here. The relational operators which we can use. The relational operators are this one. Then what are the logical operators? For and we use the conjunction symbol. For or we use disjunction symbol. For not depends on, sir, either you can use this one or you can use this one, exclamatory mark or tilde symbol. So these are the logical operators we use generally in relational operators. Right? So that is about the selection operator which we use to select the records of a relation. Now let us go to the next one. Before going to the next one, please look at this, sir. Sigma of condition 1, condition 2. What is this result? Let me select it. Suppose my condition 1 is his department must be CSC. Condition 1, department equal to CSC. Condition 2, 6 is equal to girl. So these are the two conditions. Suppose, let us assume we are in a classroom. It's a combination of all the departments, boys as well as girls, like our table. Now I want CSC girls. What I can do, sir? First, I will announce the condition, condition 2. So in this, first we are announcing the condition 2. What is condition 2, sir? I will ask all the girls, please stand up. All the girls, please stand up. Then all the girls will be in standing position. There may be CSC department girls, ECE department, EEE department. Then from that, I will ask who are from CSC. So who are from CSC? What will happen, sir? Finally, I am getting the list of all the CSC girls. Right? Instead of that one, what is the second one, sir? First, I will ask all the students who are in CSC department, please stand up. So then all the boys and girls of CSC department will stand up. Then I will ask all the boys sit down. I want only girls. Then what you are getting, sir? You are getting girls. So in these two cases, we are making announcement for 2 times. That is, we are specifying the condition 2 times separately or individually. Like all the CSC students stand up. Then all the girl students raise your hands. Now, instead of making 2 times, I can ask all the CSC girls, please stand up. So that is our third one. We are making CSC and girls. It is a single statement. So in all cases, what you get, sir? We will get only CSC department girls. Hope you understood it. So that is the meaning of this result. Now let's go to the next one, projection operator. It is used to select the columns and attributes. Suppose I have so many properties or so many attributes of the students. I want only the names of students. I don't want all the details. I don't want the department, roll numbers and everything. Just I want to know the names of my students. Then I may select only the column name. Sometimes I may need only name comma department. So I can select only those two columns. So like we can select the attributes of our own interest from the given relation. For that purpose, we use projection operator. Clear, sir? So let me give one example. List the names of all girl students. List the names of all girl students. Sir, before going to this one, first let me write list the names of students. This is the basic one, sir. List the names of students. So projection operator is pi, sir. From student you are doing. What are the columns you need? You need only name. That's it. So we have listed the names of all the students. List the names and IDs of girl students. This also we do after few seconds, sir. So before going to that one, list names comma IDs of all students. So from the student table, we need two attributes. One is name, the second one is ID, that is SID. Hope you understood it. So that is the basic, sir. Now let me write the combination of projection comma selection to answer this question. List the names of girl students. Sir, I need only the girl students first of all. So what I do, from the table student, first select only girls. So this is what we done in the previous slide. So in this result, I will have the details, all the details of the girl students. Do we need all the details, sir? No, we need only the names. So from this, I can select only the name. Clear, sir? Then what about this, sir? Hope you can write it. From the student table, first we need to select only the girls. Then we don't need all the details, sir. We need only two details. What are those two details? Name comma SID. Hope you understood it. So this is the way how to select or how to filter the columns of the relation. Now in the result of projection, we get only distinct records. What does it mean? Suppose from the student table, I have written name. Then please observe it, sir. The result I will get like this. Name. What are those? Sudha, Sita, Rama, Shyam. All they are distinct values. So I will get all the 7 records. Please observe it, sir. All the 7 names are different. But instead of this one, suppose I am selecting the department column. Then I will get the result like department. Then CSE, ECE. The next one is CSE, sir. But CSE already there. So I don't get it. That means in the result of projection, we don't get any duplicate values. We get only distinct values. So in this case, we got only 3 records because all the remaining are duplicates. Similarly, suppose I have one more student whose name is also Sita. Whenever I display the names, Sita will be displayed only for one time. That is the meaning of this result. In the result of projection, we get only distinct records. Hope you understood it. Then let me give the result. Okay. What does it mean? Sir, from a relation, first you are selecting two attributes. From that result, you are selecting one attribute. What does it mean? Suppose from this, first I am selecting names, comma, IDs. Then what will happen, sir? In my result, I will get name, comma, SID. Then first I asked all the students, what are your names and roll numbers? Then I realized or I thought that why I need IDs? I need only names. Then from this, again I will select only the names. Then what will happen, sir? From this result, I will get only the names. Right? So something like I asked all the students, what is your name, comma, ID? Then I asked all the students, tell only your name. Instead of that one, directly I can select only name from the result. Right? So what does it mean? It is like name, comma, ID. I selected first two from student. Then from this collection, I can filter only one or two. So I need only one. Why to write two details, then why to write one detail? Instead of this one, directly I can write only the names. Hope you understood it. First you collected two details for each and every student. Then you realized you need only one detail. So that is the meaning of it, sir. Right? Even not only this one. Suppose I selected name, comma, ID, comma, department of each and every student. So first I written three details. Then I realized I need only two details. Name, comma, department. Then what we can do, sir? Directly we can write only those two details. Name, comma, department. Hope you understood the result. Now look at this, sir. First you selected two attributes, something like name, comma, ID. From this you can select the name. Can we do it, sir? Yes. Whenever I have two details of each and every student, I can write one detail. Now look at this. I written only name. That means in the result I have only name. From that result, can you write name, comma, ID? No, sir. I can filter or can select the columns. But if the result is having only names, how can I generate ID, sir? Again, I need to go back to original table. I need to get the name, comma, ID. So it's not possible. So that is the meaning of it. Hope you understood it. In this case, we are getting the result with two columns. From this, you are filtering one column. But in this case, I have only one column. Whenever I have one column, can I select two columns from this? It's not possible. Here it is possible. That is the meaning of it. Now let us do one of the previous question. Just go through the question, sir. What is the optimized version of relational algebra expression? Pi a1 of pi a2 of sigma f1 of sigma f2 of R, where a1 comma a2 are sets of attributes in the relation with a1 subset of a2. f1 comma f2 are Boolean expressions based on the attributes in R. Right? Sir, the first important point is a1 is subset of a2. What does it mean, sir? Here I have selected some 2 to 3 columns like name, comma, ID, comma, department. Now from this I am selecting one or two like name, comma, department. That is the first meaning of it. The next one is these two are the conditions, right? Now look at this, sir. What is the expression they given, sir? Pi A1 of pi A2 of, here I have something, right? Before going to something, from a larger collection of attributes, you are selecting a subset. Just now we have discussed. So instead of this one, directly you can select pi of A1. Then in the bracket, what you are having, sir? Sigma of F1, sigma of F2 of R. Now look at this. These are the two conditions, condition 1 and condition 2. Instead of announcing two conditions separately, I can announce in a single statement like department and name or department and gender. So that means I can write F1 and F2. Hope you understood it. Clear, sir? So in the case of selection, we need to write and, sir. But in the case of projection, that is also whenever, especially whenever this is subset of this one, we can write only this one. So what is the answer for this question, sir? Where we are having and okay, pi A1. A1 is subset of A2. So this is our answer. Please go through it, sir. If you have any doubts, please raise in chat box. Let's go to the next one. Yeah, the same you can do it, sir. The same example I already explained. Just only for example point of view, I have written this collection. F2 of student. Instead of R, let us have student. Sir, look at, first I will ask the condition girls. Then I will get all the girls. Then I will ask CSE department. Instead of this one, I can specify CSE girls. That is what we done. Then from this list, I want only name comma department. Name comma department. That is the next one. Instead of this one, after I realized I need only name, then what you can do, sir? Directly you can write name itself. That is the meaning of it. Then let's go to cross product. Cross product we have already discussed in our earlier sessions, and we also learned in our elementary school mathematics. Let me recall it. Whenever we have two sets, suppose I have A with three elements ABC. Let us assume I have set B in which I have two elements 1, 2. Right? What is cross product of AB, sir? To write the cross product, first I consider the first element in A. Fine. I match with each and every element of B. A1, A2. Then take second element of A. Again match with each and every one. B1, B2. Then take third element C1, C2. So this is the cross product, right? Fine. Then instead of this one, let me reframe the same thing. Assume I have only one attribute. Okay, let the name will be X. I have three records A, B, C. The second set is B. There also I have only one attribute. Let us assume it is Y. Then what you are doing, sir? To form it, the cross product will contain two columns, A cross B, X comma Y. How to form X comma Y, sir? A1, A2, A1, A2. Then Consider the second element. B1, B2. Then consider the third element, C1, C2. That means the same cross product we are applying in terms of the relations. So this is the mathematics background which we need to continue our cross product operator in relations. So let's continue it. So in general, the cross product is used to combine two or more relations. No need to have always only two relations, sir. We can have even more than two relations also. Suppose I have two relations like R1, R2. R1 is having three attributes A, B, C. R2 is having two attributes C, D. Okay. Then how to form R1 cross R2? R1, R2. First, let us list out the columns of the table. I will have A, B, C, C, D. Sir, please observe it. It don't mind whether the column name is same or not. Its duty is it need to combine the columns of the first relation followed by the columns of the second relation. That's it. So this is the list of the columns of first relation followed by the list of columns of the second relation. That's it. That is its duty. Then how to form the records? Consider the first record 2, 4, 6 mapped with each and every element of R2. Then what we get, sir? 2, 4, 6, 9, 2. 2, 4, 6. What is the second matching? 6, 4. So we done it for first element. What about second element, sir? 1, 5, 7. 1, 5, 7. It should be matched with two records. 1, 5, 7, 9, 2. Again 1, 5, 7, 6, 4. So we done with the second record of the first relation. Let us go to the next one. 4, 8, 9. Again it need to be matched with two records. Then 4, 8, 9, 6, 4. Hope you understood it. Like the same process we need to continue for each and every record of the first relation, and that record should be matched with each and every record of the second relation. Hope you understood it. So this is about the cross product. After applying the cross product, I may filter some records depending on my requirement. So that is the main usage of cross product. In general, it is used to combine two or more relations. Now let us calculate the number of records in R1 cross R2. Okay. In the previous example, how many records you are having, sir? 3. How many records you are having in R2, sir? 2. Now the question is, for the record 1, how many matches you are doing, sir? You are matching 2 times because I have only 2 entries in second table. Suppose I have 10 entries. Instead of 2, suppose I have 10 entries. Then what will happen, sir? For first record, I will get 10 entries. For first record, I will get 10 entries. Similarly, record 2, we will get 2 matches. Instead of 2, if I have 10, I will get 10. Similarly, for record 3. One, 2, so on, 10. So totally how much you got, sir? 3 into 10. Hope you understood it. Why you got 10, sir? That is the number of records in second table. Why you got 3, sir? That is the number of records in first table. So can I write like this? Modulus of R1, the number of records in first table, into the number of records in the second table, right? So let me write as a formula. If R1 contains M records, R2 contains N records. Sir, modulus, my intention is the number of records. Then modulus of R1 cross R2, that is equal to M into N. Hope you understood it. So this is about the cross product. In cross product, we write all the possible matchings. We don't filter any records because we are not considering what is the value in that particular attribute or what is the attribute name. Okay, simply it's a blind procedure, just it will follow the lines. Now let us do some questions on this cross product. Consider this one, sir. Consider the following relations. P, which is having three attributes, x, y, z, Q, x, y, t, R, y, v. Fine. Then they given some records, sir, and it's a big query. Just we need to form the queue. We need to apply the operators one by one. That's it. So let us apply it. Just go through the expression, sir. We will discuss it. Fine. So first let us continue the first one. P cross R. Sir, for P cross R, what you get, sir? X, Y, Z, Y, V. So totally 5 columns. Now, before going to the answer, if you directly write all the records, how much you get, sir? For first record, 4 matches. For second record, 4 matches. For third record, 4 matches. For fourth record, 4 matches. Totally the number of records. The number of records is equal to 4 into 4. 16 you will get, sir. 16 you will get. Am I clear, sir? Then instead of writing 16, let us use this condition. P dot y equal to R dot. Yeah, P dot y equal to R dot y. What does it mean? I will explain for one record, sir. This is P dot y. This is ry. So let us consider the first record. X1, Y1, Z1, Y1, V1. Let me write all possibilities for first record only, sir. The remaining we can filter directly. Okay. Z1, Y3, V2. X1, Z1, Y2, V3. X1, Y1, Z1, Y2, V2. Fine, sir. Now look at this. The same record I matched with 4 times. Now the conditions. What are the conditions, sir? P dot y equal to R dot y. These two must be same. These two are not same, sir. So no need to write it. That is the first one. These two are not same. These two are not same. Don't write it. Right? The second condition, R dot V equal to V2. That also we can do it, sir. Let us do first condition. Then we will filter with second condition. So you got only first record. Can you tell me the remaining records? For second one, the value is Y1. So it will be matched with only the first record because the value is Y1. All the remaining I don't have matching. So that is X1, Y1, Z2, Y1, V1. That's it. Then what about third record, sir? The third record value is Y2. Y2, I have 2 matchings. So let us write those two. X2, Y2, Z2, Y2, V3. Whenever you have 2 or 3 matchings, that we need to write all those, sir. Y2, Z2, Y2, V2. Fine. Then what about the last record? Let me write it here. X2, Y4, Z4. Y4 is having any matches? Sir, no matching. So we don't get it all. No matchings. Right? Now these are the records. First record, second record, third record, fourth record. From this, again I have one more condition. What is the condition, sir? RV equal to V2. That is, V attribute value must be V2. It is not V2, sir. Please check it. It is also not V2. It is also not V2. It is V2. That means for the first part, what is the first part? They formed P cross R. From that, they used two conditions. P dot Y equal to R dot Y and R dot V equal to V2. This is the first part of this one, sir. From this, they selected only X. Okay. From this only they selected X. Suppose we not done any projection, sir. What is the one and only record you will get? X2, Y2, Z2, Y2, V2. From this, you need only the X column. What is the X column, sir? X2. So for the first part, I will get only one record. That also I will have only one column. Right? Now let us continue the second part. Q cross R. Just go through it, sir. If you have any doubts, please raise in chat box. Fine. So the second one, sir. What is the second one? Q cross R. The same story. First, let me write the attributes of Q cross R. Sir, X, Y, T, Y, V. Right? Again, I am having 5, sir. I will get all the 5. Let me explain only for first example. X2, Y1, 2. It should be matched with 4 records. Let me write all the things. Y1, V1. Y3, V2. Y2, V3. Y2, V2. Okay. Then what I need to do, sir? QY equal to RY. QY equal to RY. So this Y value must be same. I have only one thing same, sir. These are not same. Actually, here we will have X2, Y1, 2, X2, Y1, 2, X2, Y1, 2. Am I right, sir? So I have only one matching. So I will get only this record for the first one. The second condition we apply later, sir. Okay. Now let's go to the second record. What is the second record? X1, Y2, 5. Y2 is having 2 matchings. So Y2, V3. X1, Y2, 5, Y2, V2. Fine. Let us write the remaining. For the third record, X1, Y1, 6. Y1, sir, it's having only one matching. Y1, V1. What about fourth record? X3, Y3, 1. Do you have any Y3? Yes. The second record matching, sir. That's it. Then we applied only one condition. What is the second condition, sir? The second condition is QT. QT must be greater than 2. So in this, what are the records with greater than 2 values, sir? Greater than 2. It's not greater than 2, sir. Leave it. It is greater than 2. Yes, fine. It is greater than 2. Fine. It is greater than 2. Fine. Sir, please check it. These values are greater than 2. This is not, leave it. So totally how many records you are having finally? X1, Y2, 5, Y2, V3. X1, Y2, 5, Y2, V2. X1, Y1, 6, Y1, V1. So this is all. From this they applied X attribute. If you apply that one, what you get, sir? You will get only X1. Please observe it. In all the 3 records, I have only X1. So my result will get only X1. Hope you understood it. Please check it. Now let us combine these 2 parts. In first part also I got only 1 record. In second part also I got only 1 record. Right? Only for understanding purpose I written again all the entire records, sir. From this, if you apply pi x, what you get, sir? X column, that is X2. Then from this again you apply X. Right? From this again you applied X column. Then you get X1. So this is the X column. This is the X column. Right, sir? So let me write in set notation. Here I have only X2. Here I have only X1. Now for these two I need to apply minus operator, that is difference operator. Sir, we not discuss difference operator, but since we have learned this minus in set theory, we are doing this problem because the main focus is on cross product, not on the difference. Now from this, that is from the set X2, you are subtracting X1. What is the meaning of it, sir? From the first collection, if it is present in second one, delete it. I don't have anything. So this you get only X2. That means how many records you are getting, sir? You are getting 1 record. Hope you understood it. So that is what they asked. Is that clear, sir? Let us do one more previous question. Just go through the question, sir. Information about a collection of students is given by the relation student info, student ID, name, sex. The relation enroll, in which I have attributes student ID, course ID, gives which student has enrolled for what course. Fine. Assume every course is taken by at least 1 male and at least 1 female student. So we are assuming that every course is taken by at least 1 male and 1 female student. Which of the following relational expression represent? Sir, they mainly focused on cross product, sigma and the combination of the projection. Anyway, you are having minus also. Okay. Sir, I told you minus means something like, suppose in first record I have 10, 50, 60. Suppose in second one I have 50, 70, 80. If I write A minus B, what does it mean? List out all the records of A. Now, if 10 is present in B, delete it. 10 is not present. 50 is present, I delete it. If 60 is present, I will delete. So what else you are having? 10, 60. That is the meaning of it. From first relation, delete the records of the second relation. From the first relation, delete the records of the second relation. Right? Now let us do it. So I think they assume that every course is taken by at least one male student and one female student. Okay, let us take this is Rama sir. Let us have one more. So 102 taken by one girl student, one boy student, fine. 101, one girl student, fine sir. One boy student I want, right? So let me write one more boy also sir, because let's have Raju. Okay, fine. So 102 is satisfying the condition because 102 is taken by Sudha as well as by Rama, right? Then 101, it is taken by Rama. Then 101, 101, no sir. So let me write it. 101 is taken by Raju. Then 103, it was taken by Sudha. Let us take 102 by Sita. Fine. So now we are satisfying that condition. What is that condition, sir? Every course is taken by one male student, one female student. Please observe it, sir. 101, who was taken, sir? 33. Rama taken. Then 101 taken by 44. That is Raju. Then 102, it was taken by Sudha. It was taken by Rama. It was taken by Sita. Then 103. 103 is taken by 22. 22 means, let me write it. This is 103, sir. Yeah. 103 is taken by Sudha. Then I want Sita, right? So Sita. Actually, we're supposed to write like this, sir. 11, 103. Fine. Right. Now, what we need to do, sir? First, I need course IDs of enroll. This is the first one. Let me write it. So, for this, you will get course IDs. Course ID 102, 101, 103. We have only 3 courses. Fine. Then cross product of, from student information, I need male students. That is the first one. What are the, female students? Who are the female students? Sita, Rama. So these are the 2 girl students. From that also I need only IDs. That means up to here I will get all the girls. But I need only IDs. So what are the IDs of the girls? Sita, Rama, right? SID 11, 33. Fine. So the cross product of these two. What is the cross product of these two, sir? Okay, let me write it here. SID, CID. The first one 11, 102, 11, 101, 11, 103. Then 33, 102, 33, 101, 33, 103. Fine. Done it. Then from this, I need to subtract enroll. This is what we got, sir. What is enroll? In enroll, I have 7 records. Sir, you are already having on this screen. Anyway, let me write it. 22, 102, 33, 101, 33, 102, 11, 102, 22, 102, 103, then 44, 101, 11, 103. Fine. Then from this, I need to subtract it. How to subtract it, sir? Take the first record, 11, 102, it is present. Delete it. 11, 101, it is not present. So leave it. 11, 103, it is present. Then 33, 102, it is present. 33, 101, it is present. 33, 103, it is not present. Fine. So we have only two records. One is 11, one is 103. Then from this you are selecting course IDs. If you select course IDs, what you get, sir? 101, 103. They are the only two courses. Why we are not getting 102? Because please observe it. 102 is registered by Rama and Sita. That means it was registered by both girl students. Right? So whenever a course is registered by all the female students, we don't get it. Right? But when a course is registered by only some part of girls, we will get those course IDs. So courses in which all the female students were enrolled. Sir, this you are deleting. We are not getting it. Courses in which a proper subset of female students. Yes. Only some part of female students were registered. Courses in which only male students are enrolled. That is not at all the case, sir. So we are getting the second one. Hope you understood it. Right? So that is about basic operators in relational algebra. What we discussed are selection operator, projection operator, and cross product operator. In next session, we continue the second part of basic operators, that is union, set difference, rename operators. Thank you.